So I heard a lot of great explanations and reflection, a lot of good revision. Remember, re is that prefix that means again. So you're writing those steps again with the new knowledge you learned doing your lab. So now we're going to do some quick review of all the concepts you were supposed to learn by doing this lab. And we'll see how well you understand mixtures and solutions after the Ultimate Mixtures Challenge. So go ahead. Pair share, what is a mixture? Okay. Rodrigo, what's a mixture?
A mixture is two or more things put together.
Okay, two or more things put together, and they have those different properties. Okay, and how do you separate mixtures? Who could raise their hand? What tool do we use to separate mixtures? What have we been using to separate mixtures, Dylan? And can you use the frame for me?
Mixtures can be separated by a screen and a coffee filter.
Okay, and yes, Axel?
Mainly filters.
Mainly filters. How do we separate solutions? Because we can't use filters for solutions, Mildred.
We can.
So instead of saying mixtures can be separated, say for me solutions can be separated.
Solution can be separated by evaporating.
Evaporation. Tell your partner, how can solutions be separated? Okay, and we're going to do another group share using this frame. Why is particle size important? I told you I was going to ask you this. Tell your partner, why is particle size important? Good, I heard some good ideas with that. And talk with your group. Did the screen allow you to separate out the diatomaceous earth, and why? Did the screen allow you to separate out the diatomaceous earth? No. Screen are too big for the diatomaceous earth. 3, 2, 1. And why was it important? Why was the order that you did this important? Why the order that you chose for your steps? Why was that order important? Victor?
The order was important because if we filtered it with the funnel first, then the gravel and the diatomaceous earth would be stuck together, and there would be no water to separate it.
Great. I like how he used that verb filtering that when he was talking about that. The order of that filtering is important. So what did you learn this week about separating mixtures? And how do you know you learned that? So I might say this week I learned how to separate mixtures. I know this is true because how do you know you understand separating mixtures? Go ahead, share with your group. And learning bodies tells me your group is done. Okay, so we heard a lot of really good ideas. Before we totally finish, I wanted to share with you what you did today is used in the real world to filter water. Because clean water is really important. Would you want to go to like one of the creeks around here and scoop up the water and drink it? Who can raise your hand and tell me why you would not want to go and drink that, Jaden?
You might die.
Why might you die? What could be in that, Axel? And can you wait till everyone's listening carefully?
There could be bugs, some kind of poison.
Okay, there can be, what are some examples of poisons that might be in that water? James?
Bacteria?
There could be bacteria. And what? Yes?
Fish might put it back in the water.
Okay, or animals. So those can be, those have that bacteria in it. Atanol?
The creek could be polluted.
It could be polluted so that poisons, toxins, and we talked about that. If you're in my ELA class, we talked about that. So there are two ways that water gets clean. And then we'll take some more share outs in just a little bit, but we're running low on time, so I want to move on. So this is how nature cleans the water. Okay, if you went digging outside, there's all these different layers, and when the water goes through the layers, it actually filters it. So it doesn't have like a screen in nature or like a paper filter. But when water goes through things like sand, it actually stops some of those pollutants. It will take out, like, obviously, like dirt will get stuck, but also some of those bacteria and things like that will get stuck. And once when I once did a really long run and we ran out of water, and it was very, very hot, we actually drank from where water was coming out of the dirt. And we felt like it would be pretty safe because we knew the ground was filtering. And you never want to do that unless it's an emergency, because sometimes bacteria still gets through. But that filtering helps to clean the water. But do we send all of our water? Do we just get it by sending it through the ground? No, there's another way we filter it, and that's what humans do. So thumbs up if you remember learning about the water treatment plant when we had our special guest come. So that water treatment plant uses screening and filtering to clean our water. So I thought you'd enjoy seeing these pictures. So this was in the water. And they use these giant screens. And they get out, this was mostly paper and some plastic, that pulls it out. Just like you use the screen to get gravel out of your water mixture, the water treatment plant uses giant screens to get out all the big pieces of matter that's in that mixture of water and other sort of yucky stuff. Then they use filters. So there's all these filters in here, and they're filtering out those smaller particles. All the things that we don't want in the water from our showers, from the sinks, from bathrooms, all that stuff goes through here. And then where our water goes is it goes out into the San Francisco Bay. Because we don't drink that water, even though our guests told us you probably could, because it's actually pretty clean by the end. After we get it really clean, we put it back in the bay, so the bay has fresh water. Go ahead, tell your group, why is it important that we put fresh water back in the bay at the end? Max, why do you think it's important to put fresh water back in the bay?
Because if we don't put fresh water into the bay, then the fish that are in the bay, they need like really good water, so they might die.
Yeah, you're right. Excellent. Okay. 3, 2, 1, and okay. So with your group, I want you to share with your group, what do you think? And remember, this is sort of like in math. It can be the reason I gave you. I gave you 2 reasons why it's important to filter our water, right? Why nature filters it so there's clean water in the ground, and why people filter it so clean water goes into the bay. Or can you think of a different reason? Why is it important to know how to separate out mixtures? We talked about mixtures of water and other things, but there's lots of different mixtures. Why is it important to know how to separate them out? Let's take a couple hands for this one. Victor.
Because say you had a mixture of rubber bands, toothpicks, and paper clips, you would have to know how to separate them, because if they fell out, then they would probably, if they fell out of a drawer or something, they'd be on the floor all together and mixed together. You would...
Would it be as easy to use them if they were all mixed together?
No.
Okay, so being able to get what you need. If you have something mixed together and you need a specific tool, being able to pull out to separate what you need could be helpful. Desiree.
You know what Victor had, like organization of mixtures?
Oh, like a lot of you guys in your backpacks, you have a mixture of papers or in your binders. Why is it important to be able to separate those mixtures in your binders? Go ahead, share with your group.
Like you put math and
Okay, 3, 2, 1. Okay, yeah, so separating that kind of mixture, that's really important for when we go to middle school. You have an even larger mixture of different classwork, and being able to keep it separated is really important. So, we have done a lot of learning about mixtures and how to separate them. Now it's time for me to see what you've learned. So this last part is going to be independent. It's going to be quiet. Please turn your packet to the last page. And on the last page are 3 questions. And the first part's the question, and then the next part is your frame. In your science notebook, I'd like you to turn to a brand new page, put the title on top and the date. You do not need to write the question. Please just write your answer. So particle size is important when separating mixtures because, and explain why. As scientists, we really want to give good reasoning for our answers. So I'll be looking for that reasoning. I'll be looking for complete sentences. And I'll be looking for that academic vocabulary that we've been practicing. So go ahead and get started with that, please. So I'm looking for that title on your page, that date on your page, and then starting with that word particle, or those words particle size. You do not need to indent, but please do put the number. And when you're done, you're going to put your notebook on the director's chair, and then we'll be done with science, and you can take out your math test and continue working on that. So Marquise, yeah, you're going to start with this. Particle size is important when separating mixtures because. Think about your group discussions and think about your lab. Raise your hand if you're still working on question number 1. Okay. When everyone's done with 1, I'm going to stop you for just a second and talk about question 1, and then you'll finish your reflection. So why do you think the particle size was important, Jaden? So it was the sizes of the people cut the pieces of like gravel. How did that help stop it from the filter? Do you think the gravel, if you look at our screen, in order to get stopped, did the particle sizes have to be bigger than the holes or smaller than the holes to stop it? Smaller. So if it was smaller, would it stay on the surface or would it go through the hole? Go through. Okay. So was the gravel particle size bigger or smaller? Bigger. Good, because it got stopped. So that's why, because when the particle size is bigger, it gets stopped by the filters. Does that make sense, Jaden? How it stopped it? If it was smaller, it went through. So if because the particle size, if this particle size is bigger, the filter can stop it. So I know most of you are still in the middle of writing. I'm going to stop you for just a second to talk about our big idea, then you'll finish and move on to math. Okay. So one of the big ideas that we wanted to talk about was that particle size. I said I'd come back and ask you, so I have you writing about it. But I also just wanted to hear from you, why is that property of matter, particle size, why was that important when you're thinking about filtering? Why is that important? Who wants to share out? Why do you think that that's important? James.
Because if it was...
Can you use a complete sentence for me, please?
Particle size is important when separating mixtures because if you don't have the right particle size on the screen, it could go right through when you're trying to separate it.
Okay, so what has to be true about the particle size to get it stopped? Does the particle size need to be bigger than the filter holes, the same size, or smaller? Talk with your group. What do you think?
It has to be bigger.
And why? Why? Okay, if the mixture with the particles go through, is it separated?
No.
So does it have to be bigger or smaller then? Why?
Because then one of them can separate.
So who can share out why is that important? Which size do you need? Which one has to be, does it have to be bigger, the particle size, the same size, or smaller? Adalia.
The particle size has to be bigger.
And why?
It has to be bigger because if you're trying to separate it, it won't go through.
Okay, so it holds it while the other part goes through, and that makes it separate. So that's the big idea when you're using a filter. The particle size has to be bigger than the size of the holes in the filter. Okay, you guys, you did an awesome job. Please finish your writing and then move on into math. And when groups are done, I will call you over to get your materials to pack up for the end of the day.